So the next lab is probably the biggest one, and it's Lab 8 web deployment. So what we're actually going to do is we're going to put our model into production as a web service. Our goals are be able to run our prediction model as a web application. Then we're going to Dockerize that web application. Then we're going to deploy our web application not as a Docker container, but as a serverless function. So we kind of get all the three flavors, right? We'll be able to run it on our own instance, in a Docker container, and as a serverless function. Looking at our schematic, it considers the web backend. And the goal here, again, is maybe a mobile app is going to make a request. Could be a post request. The post request encodes the image. The web backend is going to be responsible for decoding that image, running it through our prediction model, coming out with a response. So like, what did we actually read in that image, packaging that up as a JSON, and then sending it to the user or in response to the request. You can open up in Lab 8 folder the README, and that will be what we're going to be doing. So the first thing to notice is that there's a new file, and there's actually a whole new folder. So let me get into Lab 8. So there's this new API folder, right? So we used to have this text recognizer folder. That's all of our kind of prediction system. And this API folder is going to be our serving system. The main file in it is app.py. And it's going to be a simple Flask web server. Flask is just a library serving the text recognizer project predictions. Ignore this for now. But from Flask, we import Flask, request, JSON, IFI. We import TensorFlow. We import the line predictor. We're actually going to, this web server is not going to run on the paragraph images. It's actually going to run just on the line images. You should, if you want, modify it to run on the full images. We're going to set CUDA visible devices to nothing because we actually don't want to use GPU for this. We're going to be deploying to Lambda. They don't have GPUs. So when we test this, we also want to make sure that GPUs are not visible. There's a little bit of what's the expression? A pony dance or something? It's a bit of a. There's a thing we have to do before we actually like get into stuff, which is instantiate the session. A dog and pony show, isn't that a thing? Yeah. Oh, yeah. Yeah. So we have to do a little bit of a dog and pony show that instantiates the TensorFlow session and the TensorFlow session graph, and then just it's unfortunate that we have to do it. It's kind of a bug on the TensorFlow and Keras side, but just know that you have to store the session that we use and then load your predictor and use your predictor in the context of the graph of that session. And a little bit of a TensorFlow detail. But we also have routes. So we have just a basic kind of health check route. A route is what we call, like in a web service, just when you hit a given URL, that's a route. Then we're going to have a /v1/predict route, which is actually going to respond to both post requests, like we had in the diagram, but also to get requests in case people want to send us links to images and not encoded images in the request. In that route, what we're going to do is we're going to load the image, and then we're going to run our predictor on the image. And we have that nice predict method. We're going to log, essentially, the confidence, the mean intensity of the image, and the prediction. And then we're going to return the prediction and the confidence of the prediction as a JSON back to the request. This image load image, it's in kind of a utility file or utility method that if it's a post request, it'll decode the image as base64 encoded data. If it's a GET request, it will read the image from the URL, which is probably going to be like an S3 URL. Otherwise, it's going to throw an error. And then lastly, we're going to run the app. And that is literally it. That's all we do. And if Keras didn't have a bug, then we wouldn't even need this code. So it's actually very easy to package this stuff up as a web server. But the next thing we want to do is actually to see it run. Let me open up the README for Lab 8. So to serve the predictions, we will just launch the application. Let's open up a terminal. Let's go to the project, lab 8, and then run this. I can switch to slides. Oh, there we go. OK. So I think it loaded TensorFlow. It loaded the model. It has the predictor ready to go. Now the web server is running. It warns you it's a development server. We're going to have to do something else if we actually want to deploy it. But don't worry about that for now. For now, we just want to test it. So we're going to open up another terminal tab. So we go plus terminal. Move that over here. Actually, let's actually move it over here. So we see this terminal up top, this terminal over here. And then in the README, there is the command we should run. And all it is basically saying, OK, our API is running at URL 000, which is localhost port 8000. And we're going to make a post request that is basically going to encode one of our test images. And the test image is going to test support EMNIS lines or if use the results. We can quickly take a look at it. So this is the image we're going to send over to to our service. Let's go into FSDL text recognizer project, lab 8, and make that request. So as you see, as I made the request here, in this tab, the server responded to it. It loaded TensorFlow. It logged the confidence, the mean intensity of the image, the prediction that we made. And then to us, it made a response, which is right here, which is confidence 0.05, prediction, or reviews the results. So that's exactly what we expected to see. And we are pretty happy, because now we're able to run the server on an instance. And also, remember how the image can be loaded as a base64 encoded file, or it can be loaded from a URL. So there's actually, I uploaded the same image to S3. Well, you're going to have to trust me that it's that image. I wonder if I put it in quotes if it'll work. I don't know. But it's that image. And if we call it with that, then we get the same response. And we saw the new request over here. So we can shut that down for now. The next thing we want to do is just add a test for it. Because we want to, we test the prediction system. But we should also test the serving system just in a simple kind of functionality test. That's going to be over here in tests, test app.py. Once again, we mask out CUDA in case we forgot to do that. And we're just going to send an image encoded and an image. Yeah, I guess we just send the encoded image. We make sure the response we get is correct. Yeah, we can run the test with just test API here. So the test passed. This is the thing that we ran, is just PyTest on the API tests. OK, great. So the next thing we're going to do is running web server in Docker. So to run it in a Docker container, we need to build a Docker image. To build a Docker image, we need to specify a Docker file. The Docker file, since it's for the API system, is going to be in the API folder. Here it is, API Docker file. So let me close this. So we're going to start from Ubuntu, actually, here. We're going to install Python, because the default Docker image for Ubuntu doesn't have Python. We're going to copy over the things we need, which is text recognizer, which is really this folder. We're going to need that. And we're going to need the API folder. We're going to need that. We're not going to need any of the training code. We're not going to need any of the WNB code. We're not going to need any notebooks. We're not going to need any tasks. So this is where Docker packages up only what you need, right? So it's as fast as possible. We install the Python dependencies from this API requirements.txt. We expose the port, and then we run the app.py. That's great, except I don't think we have this requirements.txt just yet. And the reason we don't have it is because if we look at the tasks, in build API Docker. I don't want to install pipenv on the Docker image because pipenv is a little bit of a heavyweight thing. I just want to use pipenv in my development environment to package up the production dependencies that I need. So when I build the Docker container, I will run this command. I will replace TensorFlow GPU with just TensorFlow. And then I will finally build the Docker image. So let's actually do that. So in Lab 8, I lock the requirements. Now I have all my requirements here. The next thing is I fix the TensorFlow GPU with just TensorFlow. And then now I'm ready to actually build Docker. So we start doing that. We send the stuff that Docker needs over to Docker Engine. So here it said, pulling from library Ubuntu. It pulled some stuff. It updates. This is going to take actually a little bit of time. So I'll just switch over to slides for now. So yeah, in building the Docker image, it's going to do it. And it's going to take a few minutes. And then eventually it's going to say, Docker image built, successfully built. And now we're ready to go into the next phase, which is running the app in Docker and making the requests. So this is literally the same as before. Whereas before our command was Python API / app.py. Now our command is going to be Docker run forward the 8000 port. API is the name of our Docker image. This just says, give me an interactive terminal. Text recognizer API is the name of our Docker image. And then in our Docker file, if you remember, let me open that up. The last line was run this command. So when we run the Docker image, it's going to actually execute that. So it's going to run the app. This is going to take a little bit of time to build, so I won't be able to demo it live. But this is what it would look like. Same thing. Like we just now would run the web server inside of Docker instead of on our own thing. So I think I'll pause here for some questions. Anybody have any questions about this? Yeah?
I don't think I saw where you included the model or made the model available to the API.
So in our code base, the model weights are actually stored in the text recognizer kind of package. So they're over here. So the model is defined as a combination of code and weights, and it's all stored in this text recognizer directory. In the Docker file, I copy the text recognizer directory over to the Docker image and the API directory over to the Docker image. So this contains everything I need to make predictions. This contains everything I need to run the actual web server, and that's all I need.
Is this very disjoint from the flow you showed earlier with CI and what day-to-day usage might be? Model that is
No, the way I would do it is when you run experiments, you have different potential weights, but you're running experiments, so you're trying to pick the best possible set of weights. When you do pick the best possible set of weights, your CI would commit it to the text recognizer folder in this thing here. So this is kind of like the canonical weights for this type of model. That's not the only way to do it. You could store your weights elsewhere, but you're still going to need to version them and keep them, like you still need to link the weights to the actual code. It doesn't matter to me where the weights are stored. I might as well store them right next to the code. The weights are also tracked with Git LFS. They're also not stored in Git directly. They will get uploaded to S3. So.
Kind of a clarification question. You mentioned an optional Lab 9.
Uh-huh.
Where can people find that?
Oh, that's a good question. So the FSDL text recognizer project, I should just, well, maybe I'll do this later, but this is actually generated by FSDL text recognizer, a different repository, which is FSDL text recognizer. And this repository generates the project. So in here, there's instructions for Lab 9. So I think what I'll do is I'll probably just copy that over as Lab 9.
Okay.
I see it as optional because it really focuses on monitoring of a running service. And it's kind of a nice to have for this set of labs. It's not crucial.
You talked about continuous integration. Are there also continuous deployment tools for ML that are worth talking about?
So continuous integration, sometimes it's written as like CI/CD, continuous integration / continuous deployment. I just kind of fold that all into continuous integration because once your tests are passed, what you might want to do is upload the resulting model somewhere. But because the tests that we run are not actually training the model, continuous deployment makes less sense to me in this case. But in other repository setups, you might actually want to train the whole model every time you push code. It might make sense to do that if your model is small, if your data set's small. If you have if training takes a long time, then it doesn't make sense. You have to have some separate process for deploying models. But if the training time of the model is small, you can actually do it as part of your continuous integration. What I think makes more sense is just have a regular schedule for training or actually a manual process for training. Because unless your data automatically improves every day or every week, there's no point in training every week if it's the same data and the same code. It doesn't make sense to train every time you update code because sometimes you're just exploring stuff, or maybe you don't want to train this specific model. You just change some other part of the code base. You don't need to retrain everything. So I think it makes sense to have either a scheduled or a manual process for kicking off model training.
I want to also clarify the question. I meant mostly when you're continuously deploying your model, then there's going to be metrics that based on that you might want to continue using, like some sort of like A/B testing, and then or like deploying it on a small percentage of users, and then see what is the effect, get feedback, monitor it, and then deploy it to all users. Is there such a tool for that?
Yeah, so part of the all-in-one solutions do stuff like that.
Okay.
So there are definitely tools for that.
Shadowing.
What's that?
The shadowing, or like just picking like a small number.
Yeah, to repeat the question, it's are there nice tools for, canarying models, maybe shadowing, so like two different versions of the model run in production, but only one is exposed to the user, the other is just silently recording what it would do. Yeah, there are tools for that. So like Seldon, I think, would be something that you should look at on top of Kubernetes and Kubeflow. Some of these all-in-one things like Domino, I think, make that possible. And in general, yeah, if you sign on to their deployment like pipeline, I think they make stuff like that available for kind of hacking it up yourself. Yeah, I think Kubeflow, Seldon, that's what I've seen. But that's a good question. Yeah, and there's also DevOps standard practices that even for web servers, sometimes you canary new versions of code. So all of that can be applied to machine learning. Yeah, so in general, I think it's worth thinking of deploying machine learning not as like a exotic different beast from deploying anything else, but assume that it's the same as deploying anything else. Hopefully, if you have DevOps people, get them to do it for you because it's not so different. But if you find that there is a reason to make it different, for example, you need to use GPUs, at that point, we can worry about how to make it different. But for now, I just encourage people to treat it as deploying anything else. So I think I'll go on to the next thing. So my Docker got built. I won't run it. It works. You can do it. The next thing I want to cover is deploying actually to the serverless function host AWS Lambda. We're going to make use of a library called serverless to do so. So there is a task script in here called deploy API to Lambda. And it locks the requirements just like we did before. It does this npm install, which installs the serverless framework. And then it does serverless deploy. So let's go ahead and just run that. well, actually, we can do it step by step. So npm install installs this framework called serverless, which makes it's helpful for us to deploy these serverless functions. OK, so it's successfully installed. Unfortunately, I need to let me open up that README again. I need to export my path a little bit. OK, so now I have the serverless command, and I can say serverless info. And it'll say, OK, service information, text recognizer username. OK, where's that coming from? Where's all this coming from? So it's coming from API serverless YAML. And so the service that we're going to be deploying is called text recognizer username. So OK, I'll make it Sergey K, right? What we'll do is we'll package up our code. We'll exclude basically everything in Lab 8 except for text recognizer and app.py in this folder here. The provider we're going to deploy to is AWS. This is the region. This is the runtime. Memory size 3 gigs. Timeout 30 seconds. Not going to version functions. That's a nice thing to do, though. And then the function that we'll deploy will have basic execution, so we'll be able to write the logs and so on. The function that we actually want to deploy is this is kind of like a shortcut, I guess. So we have this app.py. It has all these routes, right? There's the index route, the predict route. We really only care about the predict route. But if it was more complicated, if it had different routes, this thing would basically turn each route into an endpoint on Lambda, which is just a nice thing to do. Otherwise, if we didn't need to do that, we could just only deploy this specific function, essentially, as the handler function. And then lastly, yeah, the WSGI, that's kind of what runs the web server. So app.app is going to be the thing that is the web server for us. And then Python requirements is an interesting thing. We're going to build this whole thing inside of Docker, which this Docker image is going to be special because it's actually the Lambda runtime environment. So we're going to build everything in the same environment that it's going to be deployed in, as much as we can get it, using Docker. We're going to slim down all of the requirements. So we're going to delete test files, delete a bunch of stuff. So for example, we're going to delete TensorBoard. We don't need it. TensorFlow contrib. We don't need it. We're going to strip all the binary files except for CV2 and H5Py for an arcane reason. And we're going to zip up we're going to double zip the package. Don't worry too much about it. But what we're going to do now is just, did I save it? Serverless deploy -v so we get some verbose output. So this might take a while. I think I'll just switch the slides. If you run task deploy API to Lambda, you'll go through the same thing. It'll say, start going through what it does. In a few minutes, it'll finish, and it'll say, OK, the endpoint is now live. And I don't know if you can see, but over here it says endpoints, and it gives you a URL. So that URL is actually our deployed model now. Here it is. So this is one that I did, I think, a couple of days ago. It might still be live. So what I can do now is, well, I can wait for this to finish, but it might take a few minutes. If you're following along, you're also going to need an AWS account, which, in the weeks to come, I encourage you to follow along just to not be afraid of this. But yeah, if I replace this with what I see here, LG4, EKTTC, 2A. So this is something I deployed a couple of days ago. So if I do that, I'll start a new terminal here. 8. This first request is probably going to fail. And that's because, So Lambda's nice, but it's not magic. So the resources still have to be provisioned, and it still takes Amazon some amount of time to provision the resources for executing our serverless function. The first time you execute it is called a cold start, and it can take anywhere from several seconds to maybe a minute. The second time you call the function, it'll execute immediately. And then, so this one timed out. Let's just wait a little bit. And so the scaling, there's still some time to wait for something to, if you all of a sudden start getting hundreds of requests per second, the first 100 are going to fail, and then hopefully you start being able to actually answer them. I can also log into AWS to look at my console. I think I'll just show you the slides, actually. So yeah, this is the one I deployed a couple of days ago. This one's called Text Recognizer Sergey Karyev Dev. And this is what it looks like. It provisions this whole stack of the AWS endpoint, AWS Lambda, and S3 bucket for uploading the Lambda zip file. So this is known as a CloudWatch stack, CloudFormation stack. This is the actual Lambda function it created, Text Recognizer Sergey Karyev Dev API. The Lambda function, it's able to write to logs. It's able to receive events from the API gateway, which is another thing that gets created. And then as I make a request to this Lambda service, so here I curl the API URL, which is this Lambda URL. I get back a response, same one that we used to get when we were in it on our local. And then we see the logs for the Lambda now in CloudWatch. So this is pretty much the story. Let's see if it works again. Yeah, so the first couple of requests timed out, but now the function is live, and it'll respond as quickly as it used to. That is the basics that I wanted to cover. In the README, that's about it. There's Lab 9 that's optional that I said, which basically deals with monitoring, but it's difficult to execute in this environment. So that is it for me. Are there any questions that you guys have about deploying serverless or Docker?
Any recommendations on A/B testing of models?
So software for A/B testing of different models. I'm not sure that it's crucial, because the process by which I imagine you deploy the model includes evaluating all the possible models during your training and evaluation phase on your validation set. So you've selected the model that works best on your validation set, and you will deploy that model. That's the mental model that I have. If you wanted to deploy multiple models, which ones would you deploy, right? Would it be like the top 3 on the validation set, or would it be just some random ones, or would it be the new one versus the old one? The new one versus the old one, I can see the benefit of, but ideally the old one is also run on the validation set, and you've shown that the new model is better than it on the validation set, and that's the reason you're deploying it. So I don't have a concrete recommendation for A/B testing beyond using stuff like Celdon or one of these all-in-one providers like Domino. But I would question what problem we're trying to solve with it, because if the problem is that we want the model of the best performance, I think the time to ensure that is in validation. And if you consistently can't predict which model is going to be best in production, then I would say you probably don't have enough data, and the solution to that is not A/B testing, but potentially just gathering more of the production data, putting it in your training and validation sets, such that your actual training and validation set distribution is reflective of the production data set distribution. And if you guys have tips for A/B testing, then please post them in Slack.
There's a question around, so you're deploying a model in some containerized environment into production, and then ultimately what you want to do is capture the data back from that production environment so they can use it to retrain the model. So do you have any tips for how you can use, like take what you've deployed into production and use that to update a database that you can then use to train your model on?
So maybe the question is, like my model makes a prediction. If the user doesn't correct it, I can assume it was a correct prediction, so I can put that back into the data set? Is that?
Yeah, so like suppose that you have some way already of putting the data that the model sees into, like, let's say let's say you have like an API where a user is submitting a photo, and then they're saying whether they liked the output of the model or not, right? So how would you get the photo and the label that they provided, as well as the prediction of the model, back into a database so that you can retrain on them?
Yeah, I think it's kind of goes to that pay attention to the data flywheel set of slides that I had in the testing and deployment lecture. I think it's going to be slightly different for different use cases, but it's just, it's good to set something up, but it's, yeah, I don't know if there's like software that helps you do it right now.
Maybe we can open it up if there are other questions.
Marcel?
Could you talk a little bit about your approach to a canary deployment with Lambda and the flow involved, the workflow?
Yeah, so the canarying, once again, it refers to directing some part of request traffic to one model and some part to a different model. So with this lab-suggested system, the requests are routed to Lambda through this API gateway, which is set up by this whole stack. So I think I would change the API gateway to send some traffic to some version of the model and some traffic to the old version of the model. I don't think Amazon makes it easy to do. So I think you'd need to, I don't know offhand how I would do it, but it's possible. It's just not like a first class, I think, option in this config. So if you deploy with SageMaker, one of those all-in-one solutions, then you deploy a model to SageMaker, and they give you UI for like canarying.
There's a UI for like production variants where you can put weights for two models, two versions of the model, so you can have one model, serving amount, whatever percentage you actually want.
Cool. So yeah, I would expect the all-in-one solutions and the like deployment-specific solutions like Algorithmia to provide that stuff. In this Lambda setup, I'm not offhand sure how to do it right now. Yep.
Can you explain a little bit about the serverless functions, like or functions and service, like besides the fact that pricing and compute, what is their advantage? Like what do they mean?
The advantage is that you don't have to worry about the resourcing of your scale. So if your scale increases, Amazon takes care of launching more essentially instances that can serve those requests. What it means in practice is that Amazon has machines that are basically have multiple functions loaded in memory, of which yours is one. And then if a request comes in, it gets routed to the right place. Your function processes it. That's how it works. But the mental model is still, there's still hardware running your code. It's just that you're not in control of provisioning it anymore. You've yielded to Amazon the power to put your code on whatever compute it wants to. And all it promises to you is that you'll have at least 3 gigabytes, or exactly 3 gigabytes, and like some amount of runtime. One upside is that it only charges you for that runtime. So if it executes for 2 seconds, you'll get billed for 2 seconds. The downside is that the amount you get billed for 2 seconds is higher, per second than you would pay if you actually provisioned your own machine. So if you provision your own machine, maybe for a second you'd pay like 1 cent, but on Lambda you'd pay 2 cents. So you're gaining the advantage of not worrying about it, but it's a little more expensive. A downside of it is also the resource constraints. So it's like 3 gigs at most, which I think works for some stuff and not going to work for other stuff. And I think the dream, and that's going to be the future, is basically doing this except with Docker containers. So if I can package up a Docker container, just push it somewhere, and then basically treat it as serverless. Like, I don't care where it runs. All I know is that my Docker container is going to have, 4 gigs of RAM, 4 CPUs, maybe even a GPU. I don't control the resources. I don't care about scaling it. It's just automatically done for me. Unfortunately, we're not in that world just yet, but we will be. That's where it's trending. I think we can end early and maybe start Peter's lecture early if possible, because it usually goes over. OK, well, thank you.